Lesson 5.2, perpendicular and angle bisectors. So let's say you're going to hang this bulletin board over the desk using the string. The bulletin board is crooked. When you straighten the bulletin board, what type of triangle does the string create or string form with the top of the board? So as this string starts to slide this way, as you move this, it becomes a little more straight. It should form an isosceles triangle, where these two strings would be the same distance away from each endpoint. That distance is called, that word is called equidistance. A point equidistance from two objects is the same distance from the object. So that means that when this thing straightens up, so we'll put a line here. So as this board begins to straighten up across here, this distance going from here to here is going to be the same distance. Okay? So we have these two lines become equidistant, therefore these two are going to be the same and form an isosceles triangle. So let's take a look at here. Theorem 5.2, the perpendicular bisector theorem. If a point is on the perpendicular bisectors of a segment, then it's equidistant from the endpoints of the segment. So if we have a point, okay, somewhere on this perpendicular bisector, we know it's a perpendicular bisector because it meets this side at a right angle and it cuts this segment in half. So what this means, it's saying that anywhere this line is, this point, you can draw a line from to either endpoint and it's going to be the same distance. So if I came up here to the very top, then these 2 points would be, these two lines that I just drew would be the same. I could come down here and these two. So any point that's on the perpendicular bisector is going to form an isosceles triangle with the segment that's already there. So I could go from this point here and be very close to it, and this would still form an isosceles triangle. So that's what you're saying here, that PA is going to be congruent to PB. So the converse of this is saying that if a point is equidistant from the endpoints, so if this point here is the same distance away, which means you have an isosceles triangle, then you could draw a segment down from the vertex angle, right here, down to the other side at a right angle, and it would be the perpendicular bisector. So it would be perpendicular to the opposite side, and it would cut it in half. Similar to what we looked at in our last chapter, when we bisected the vertex angle of an isosceles triangle, which is what we're doing here. We're cutting this side right here. So if this is the perpendicular bisector, then by that theorem we learned, this angle would be congruent to this angle. This would be bisected, which means you have two congruent right triangles. So let's look to see how we'll use this. What is the length of AB? So we're just going to kind of answer the following questions here by what we know. So look at our diagram. We can see that AD has been cut in half, or AC has been cut in half at a right angle by BD. So this BD is the perpendicular bisector of our segment AC. So what that tells us, it tells us that the distance of these two sides here are going to be congruent. So we're going to take 4x and set it equal to 6x minus 10, because we know that our segments BA are going to be congruent to segment BC. So now we solve for x. So when you have a variable over here, the smaller variable is on the left, and we have a number over here. So we're still going to try to isolate our variable, so this time we're going to take the larger variable to the smaller. And it gives us a negative variable, which is okay. Negative 2x is equal to negative 10. When we divide by negative 2, this becomes a positive x, and this becomes negative 10 divided by negative 2 is a positive 5. So what is the length of AB? Well, we're going to plug it back in. So AB is equal to 4 times 5, and that's going to give us the length of AB is equal to 20. You could check it by plugging 5 into here. 5 times 6 is 30. 30 minus 10 is 20. So they are the same length. All right, you guys try this next one. What is the length of QR? So we know that QP is congruent to QR because this is the perpendicular bisector. QS is the perpendicular bisector of PR. So we know that they're congruent, so we can take 3n minus 1 equal to 5n minus 7. Solve for the variable n. That's going to give us that n is equal to 3. Plug it back in for QR. That's 5 times 3 minus 7. That's 15 minus 7, which gives us 8. So you can always double check it by plugging it over here. 3 times 3 is 9, minus 1 is 8. So the distance from a point on a line, point to a line, is the length of the perpendicular segment from a point to the line. So the shortest distance from this point to this line is this perpendicular distance. And from B to this line, it would be also the perpendicular distance, the distance at a right angle. So theorem 5.4 talks about the angle bisector theorem. If a point is on the angle bisector, so this line right here would be bisecting our angle, PQR, cuts it in half, then that point is going to be equidistant from both sides of the angle. So the distance we would choose would go this way, and therefore it would bisect it. So if QS bisects angle PQR and SP is perpendicular to QP and SR is perpendicular to QR, then SP is congruent to SR. So their distances would be the same. They're the equal distances from both sides of the triangle, of the angle. So the converse of this theorem says that if a point is on the interior of an angle equidistant from the sides of the angle, then this point right here would be on the angle bisector. So if these 2 points are congruent, so if we get a picture like this and we have a point here, same distance away from both sides, then you can draw a line from Q through S here, and it would bisect your angle. So QS would be the angle bisector of PQR. So let's look at some problems that we'll encounter using this theorem. What is the length of RM? So this is going to be kind of a matching up thing. So we can look here. As we look at RM is right here. We know that this angle is bisected because of these two arcs. So therefore, this distance here would be the same as this distance here. So we would say that 7x is equal to 2x plus 25. And now we just solve for x. So we subtract 2x. 5x is equal to 25. Divide by 5. And x is equal to 5. So now we got to go back and plug it in because we're looking for the length of RM. RM is going to be 7 times 5, which is going to give us 35. You can always double check it here. 10 plus 25 is also 35. All right, let's take a look at B. So in this question here, in example 3, how far is M from JK? So I want you to attempt parts A and B, pause your video, come back and check your answers when you're done. All right, so as we look at this figure here, here's one thing to know about this picture, okay? We know these segments are congruent because they're marked congruent. This is 8 over here. That means that this segment is also 8. They're the same length. Now, we know this segment is perpendicular to this side of this angle, and this is perpendicular to this side of the angle, which means that if they're the same distance, then this right here is the angle bisector, which means this angle here is the same as this angle here. So that helps us find the value of x. If this is 54 and this is supposed to equal 54, you set them equal and solve for x. So that cancels our 3. 54 divided by 3 is 18. So this gives us 18 for x. So now let's take a look at the next two. So next two, we have the same diagram. We're just now going to answer different questions. Find the measure of angle MKJ, and then I want you to find the measure of angle JMK and angle JML. So answer these last two questions and pause your video and come back and check your answers when you're done. All right, so looking for the measure of angle MKJ. So this is this angle over here, and since this angle is congruent to this angle, these are both 54. So that's the answer to the first part, for part C. Now for the measure of angle JMK, that's JMK, that's looking for this angle right here. So if this is 54 and this is 90, then we have a right triangle. So to find this angle up here, we're going to subtract it from 90 to get 36. This angle is 36. Now, because this angle has been bisected, okay, then this angle is congruent to this angle. We know these two angles are congruent, which by the third angle theorem, these two angles would be congruent. So this would be 36 as well. So what is the measure of JML? Well, it's the sum of the entire angle from here to here. So that's going to be 36 plus 36, which is 72. All right, so this concludes our lesson on perpendicular and angle bisectors.